Good morning, one and all. Today we are discussing about basic geotechnical engineering, 5th semester, 18Cv54, module 1, lecture class 3. So the content of today's presentation are phase relationship, definitions and their relationships. So here, as I said in the last class, soil composed of soil solid, water and air. Therefore it has derived a name, three-phase diagram. Soil solid is first phase, water is second phase, air is third phase. So if you take a known volume, let us say VT, this total volume of soil. In the total volume of soil, the space occupied by the soil solid is Vs, the space occupied by the water is Vw, the space occupied by the air is Va. As the air and water, Va and Vw, is occupied in the void space of the soil sample, therefore it is called as Vv. Vv means volume of voids. Okay. Now, if it has occupied some volume, means definitely it should have some weight. Therefore, soil solid, we are calling it as WS, the weight of soil, whereas water will also having some weight. Even though density is 1 gram per cc, it should have some weight. Therefore, weight of water, it is symbolically represented it as WW, and air will also have some weight. No doubt the weight of air is less than the weight of water, but it having some weight, therefore weight of air. But all practical purpose for our derivations, we are considering it as 0. Okay. So the total weight of that volume is Wp. So now this is a symbolic representation of three-phase, two-phase diagram. Now this one is a three-phase diagram. So where air and water is there in the voids. This is a two-phase diagram. This is a two-phase diagram. The difference is all the voids has been occupied by water, means then it is fully saturated two-phase diagram. If all the voids has been occupied by air, means it is a fully dry two-phase diagram. That means to say, so if during rainy season the voids has occupied by water, or if a saturation takes place, submerging takes place, it is occupied by water. Therefore, it is a fully saturated two-phase diagram. During summer, evaporation of water from the void space takes place, or some draining out of water from the void space will lead us to a two-phase diagram with a full dry soil. Now, we will make a definition for the three-phase diagram terminologies. Degree of saturation, yes sir, it is a ratio of volume of water to the volume of void space in a soil mass is called as degree of saturation. So degree of saturation is represented by symbol SR, VW divided by VV. Then porosity is given by symbol N. It is a ratio of volume of voids to the total volume of soil, so that is VV by V. Next is void ratio. So void ratio is defined as a ratio of volume of voids to the volume of soil particle, VV by Vs. So next we have to discuss about some more definitions. Bulk density, that is mass or weight of total soil to the mass or weight of that is total soil to that corresponding volume, MT by VT or WT by VT. So dry density is given by dry weight of the soil particle divided by original volume. When we say dry density, we are not considering air weight or water weight. We are considering only the weight of the soil particle. Next, buoyancy or submerged density. Submerged density is whenever a soil is immersed in water, a buoyancy effect will come into picture. That means apparent weight loss will take place. Therefore, so we have to deduct the density of water from the total density. So the total density is rho minus rho W we have to deduct it. That will give buoyancy density or submerged density. So you please go through the MCQ questions which are uploaded in LMS software and answer it. If you have any doubt, next class you can ask. If you have any doubt, you can ask. If you don't have doubt, thank you for attending.